Okay, today we're going to be solving compound inequalities. Yesterday we did multi-step inequalities where you would graph a point and that solution was either greater than or less than that number. And so you would have an arrow where the solutions were basically to infinity in that direction. Today with compound solutions, we're going to have and or statements. And the reason they are different is because with and statements, you have a beginning point and an ending point, and the solution is going to be every number in between, not with an arrow going indefinitely. With or statements, you're going to have 2 points. One's going to be greater than, one's going to be less than, so the actual solution is not the numbers between the 2 points, but the solutions on both sides. So we're going to see how that plays out here. In our first example, we have an and statement. We're just going to solve these separately. You have one-step inequalities here. So in order to get x by itself on this first one, we just subtract 2 on both sides. When you do that, the 2's cancel out, and x is greater than or equal to 2. If you like to see it better, we can flip it this way. If we were to graph that, we would go down here to 2, color in a dot, and we know it's greater than that. When graphing the second one, we subtract 2 on both sides of the equation. So x is less than or equal to 6. So again, we go to 6, we colored in dot, and it's less than that. Notice that the line connects them. We call these and statements. And we can remember it this way. If it's an and statement, they are holding hands. It's like you have 2 people, and they're holding out their hands to one another, so the line goes between. Ands, they're holding hands. So the solution is going to be all of the points, all of the numbers between those 2 points. In this one, it's also an and statement, but instead of using the word and, they write it with 2 inequality signs. Because there are 2 inequality signs, that actually divides this inequality to 3 parts. The part on the left, the part in the center, circle, the part on the right. So we are going to have to get the variable by itself in the middle. Here's what you have to remember. What you do to one part of the equation, you must do to all parts. And remember, there are 3 parts. So if you look up here, we have x in the middle. First, we need to subtract 3. When we do that, it cancels out in the middle, which we want it to do. But we have to do it on all 3 parts. In the middle, we have 2x left. It is going to be greater than or equal to a negative 8, and it's going to be less than 6. Now, in order to get x by itself, we're going to divide all 3 parts by 2. When we do that, the 2's cancel out, and we have x is greater than or equal to negative 4, and x is less than 3. So when we graph this, we know we're going to go to negative 4 with a colored in dot, and we go to 3 with a circle dot. Since it's greater than negative 4 and less than 3, we see that the 2 dots are going to hold hands. That means the solution lies everywhere negative 4 and all of the points between those 2 numbers. And is holding hands. The lines come together. Here's another example. Again, we have 3 parts to this inequality, and we want to isolate the n, get the n by itself. We begin by subtracting 5 on all 3 parts of the inequality. That leaves us in the middle with 3n is greater than or equal to negative 9 and less than 6. Now we're going to divide all 3 parts by 3. When we do that, we have n is greater than or equal to negative 3 and less than 2. So to graph, we go down to negative 3, colored in dot. We go to 2, circle dot. Since it's less than 2 and greater than negative 3, they connect, they hold hands. So there is your solution. In our next example, we have the first or statement. When you have an or statement, it will actually use the word or. It will be very specific for you. And I want you to picture a person in a boat with 2 oars. If this was a point and this was a point, and the or goes out, you're going to have 2 inequalities going in opposite directions. like two oars on a boat. We're going to solve them separately and graph them. So if you look on the left side, to get a by itself, we need to add 4 to both sides. So when you do that, you have a is greater than 5. So when we go down here to graph it, you go to 5 with a circle dot, and it's greater than that. On the other side, we add 4 to both sides of the equation. So we have a is less than 1. So we go to 1 circle dot, but it's less than that. You can see here the two oars. You can imagine a person on a boat with two oars, and they're oaring. The solution is everything on both sides, not in the center. So 2 is not a solution, 3 is not a solution, 4 is not a solution, or any of the decimals or fractions that go with those. But it's everything greater than 5 and less than 1. So it will graph in opposite directions like that. On this example, again, we have an OR statement. Simple one-step equations. We're going to divide both sides by 2 here. We have x is less than or equal to 3. So if we were to graph that, x is less than or equal to 3, we go to 3 with a circled in dot and go less than. On the other one, we divide both sides by 3, and we see that x is greater than 4. So we go to 4, circle dot, going to the right. So there's a very narrow margin of numbers right here that is not the solution, just in between 3 and 4, but 3 could be a solution. It's important to be able to look at an inequality and be able to write the equation. First thing you do is decide is it an and or statement. Well, this is our ors, so this is an or statement, so we're going to start by putting or. Then you just look at this and write an inequality for that. We're just going to start with x. Well, what about this number? It's less than, because the arrow is going to the left, not equal to negative 6. On the right side, we have x is greater than or equal to, because we have a colored in dot, 0. Very simple to graph. Okay, this is again is an example of an or statement. So on the left side, we have x is less than or equal to negative 4. Or on the right side, we have x is greater than, but not equal to, negative 2. How do we graph an and statement? The easiest way to graph an and statement is to begin by putting an x. We know that x is greater than one number and less than another number. So you can just start by putting your x with your two less than signs on each side. We look up here, we see that this one is equal to, so we're going to put our equal to sign here, and then we simply just put that number, negative 8. We look over here, we have it is not equal to, so we just look at the number and bring it down, 4. X is greater than or equal to negative 8 and less than 4. That's simple. Let's look at another example. And this is an and statement, so we know x is going to be greater than a number and less than a number. We look up here, use a different color. It's not equal to 2, so we put a 2. It is equal to this number, so we put our line underneath and we bring down the 8. It's that simple. Here is the first example on your work page today. Make sure that you solve and you find the graph that matches it and put the letter beside the answer. That concludes the lesson. Good luck.